Hey, this is Mr. Bus, and in this video I'm going to go through this problem that you'll see in the Schoology quizzes. This is the one about the chi-square Pea Plant Cross. This is kind of similar to what I'd done in the worksheet video, except I don't give you the Punnett square, so you kind of have to figure that out for yourself. Okay, so in this problem we're going to do a standard Pea Plant Cross where we're talking about traits that you've heard of before and stuff like that. So we're going to cross a tall pea plant with heterozygous tall with heterozygous tall, okay? And the offspring are going to be more tall than short. And we want to know if these are the observed. The observed is 47 tall and 29 short. We want to know if that is close enough to what we'd expect to say that, that our null hypothesis holds true. That the pea plant tallness trait is determined by one gene with two alleles, capital T, which is dominant to lowercase t. I mean, we know that it is, and honestly, this probably isn't enough data to really make a claim. We'd probably have to make a lot more crosses than this for the statistics to really hold up. But let's go ahead and work this out. We can still work it out and see what the right answer is and stuff like that based on this data. So we have to know what our expected is. Again, observed is given to you. What is expected? Once we know expected, we can do this problem. So, got to make a Punnett square cross. We're crossing heterozygous tall with heterozygous tall. And you guys know how to do that. Okay, so those are all going to be tall. So 3/4 of the pea plants are expected to be tall, and 1/4 are expected to be short. Okay, now that's great. We know our expected ratios, but I want to know what are our expected numbers of offspring. Okay, how do we do that? Well, if we had 47 tall and 29 short, okay, what's our total? 47 plus 29 equals 76. So of these 76 pea plant offspring, how many would you expect to be tall? Well, 3/4 of them. So if I take 76 times 3/4, I say to turn my calculator back on, 76 times 3 divided by 4 equals 57. I would expect 57 of the 76 to be tall. And short, if I take 1/4 times 76. So 76 times 1 divided by 4, 19. So these are our expected values. Expected 57 tall and expected 19 short. Now we have everything we need to run this. We're going to have to figure out what the sum is. Well, we're going to have to run this twice because it's either tall or short. Okay, so we have to run this for tall and we have to run this for short, and then we have to add up the chi-square values. So here we go. 47 minus 57 squared divided by 57. And then for short, it is 29 minus 19 squared over 19. So we'll go ahead and crunch those numbers. They both happen to be the same. So it's 10 squared over 57, which is 100. So it's 100 over 57. And this is going to also be 10 squared over 19. So it's 100 over 19. So I'll just do that. So this one equals 1.75. And this one equals 5.26. Add them up. You get about 7.0. So that would be our chi-squared value, 7.0. Oops. Okay, so far I've helped you answer what the expected values are. I've helped you calculate what the actual chi-square value is. Let's take a look at the table. How many degrees of freedom are there? Well, it's either tall or short. -1 is 1, so we're looking at 1 degree of freedom. And I told you in the problem to look at the 0.05 p-value, so the 95% confidence. So we're going to look at this number right here. If our number is less than that, then we have a very small amount of deviation, and our null hypothesis is true or accepted, or you could say you can't reject it. But our value is higher than that, and so we'd have to come up with an alternative hypothesis, like the genes may not be completely dominant to each other, or maybe I did the wrong cross, or something else is going on here. Now, we know that the genetics is good for this. It's just I just decided to throw them together to see if you can solve the problem. So we would have to, in this case, reject the null in favor of an alternative hypothesis based on the data anyway. But you'd probably say we'll probably just need to do more trials, because 76 offspring isn't very many. We could probably run this more and see if the numbers actually smooth out, if we actually do start to see 3/4 tall and 1/4